this video, we are going to discuss the problem message routes, which is from CSES.5. It is a very basic problem on graph. It is based on BFS. Cool. So first, let us read the problem statement, guys. So the statement goes as follows. So the time limit is 1 second and memory limit is 512 MB for us, guys. Cool. So the problem is Silsila's network has n computers and n connections. Your task is to find if Uluvi can send a message to Marzi, and if it's possible, what is the minimum number of computers on such a route? Right. Cool, guys. So the input format is the first input line contains n element, two integers, the number of computers and the connection. The computers are numbered 1, 2, and n, guys. So Uluvi's computers and Marzi's computers is n, 1, and n. So there are m lines describing connections, e minus two integers a and b. There is a connection between those computers. Every connection is between two different computers, and there is at most one connection between any two computers. It's possible to send a message. First, print k, the minimum number of computers on a valid route. After this, print an example of such a route. You can print any valid solution. If there is no column, no routes, print impossible. So I hope you have got the problem statement, guys. So this is the sample input, and this is the constraint, general constraints from a graph question, 10 to the power 5 nodes and 20 into 10 to the power 5 connection. Very basic, guys. So to get the better understanding of the question, guys, I would like to draw here for you some notes, and so that you can grab the question. Wait, guys, let me put. So these are notes, guys. These circles represent nodes here. Cool. So first node, second node, third node, fourth node. So in the question, it was mentioned that, let me so in the question, it was mentioned that one is connected to 2, one is connected to 3, one is connected to 4, and 2 is connected to 3, and 5 is connected to 4. Cool. So this was the graph given to us. It looks like this visually, right? So we need to find the shortest path from node 1, which is here, guys, as I'm pointing out, to node n, in this case 5, which is this, guys. Shortest path. So we need to find the minimum number of computers required in this connection. So basically, we need to find the shortest path between the two given computers in this network, which is nothing but this thing, this here, and this here, right? So if we have the distance n, x, for example, so the number of computers involved in this connection should be x plus 1. Cool, guys. So here we can use BFS, which we generally use while traversing graph, and we need to find the shortest path. So this question can be basically done by BFS, which is level order traversal. So I think we can now move to the code section, guys. Cool. Let me just a second. So I have copied the input, guys, and now we can write the code. So I will go with my simple snippet, which is been shown to you earlier in the course. Nice. And now, so many people tell you about creating graph using node and all, but I will go here for the wide approach, which is generally used in CP, guys, and I recommend you to use it in CP, guys. The graph approach will be helpful for you in interviews, but for CP, guys, this approach is the best, I think. So we will follow the constraint and create a vector int or a, which denotes adjacency list, and we will give it size 10 to the power 5 plus 1. We will create a vector bool listed, just general basic BFS, guys, nothing new. You all know this. And we need the distance, so we need to create a distance array for each node. And for printing the connect path, guys, we need to store the parent of each array. So nodes, guys. So storing the parent of each node, we will use the parent array, guys. Now from the input format, we can code the input we can take the input like this. So we have n connections, so while n minus minus, we can take the two nodes having connections, x comma y, to seeing them. Basic price, nothing new. And what we can do now is push back the x in the adjacent, put back y in the adjacency list of x, and we can push back x in adjacency list of y, right? So we have taken the input, guys. And now here we just need to do BFS one, and now we need to check if distance is less than equal to 0. Distance of n is less than equal to 0, then the answer is impossible, right? It is returned from this function. And if the answer is not impossible, guys, then in this case we need to see out distance of n plus 1, as we discussed earlier, like distance of n, because this is the distance to, and the number of computers involved in this connection is x plus 1 if the distance is x, guys, right? So cool. And now we need to get the path. So for getting the path, I will create a vector in path which will store the path in the reverse order. So while n is not equal to minus 1, we can answer, we can push back n in a path and make n equal to the parent of n. So guys, as we have stored the parent in this array, so guys, we need to jump. Let me share this. So the parent of 5 is 4, the parent of 4 is 1, and we can create the parent of this source as minus 1. Let me draw it clearly, guys. So parent of this as minus 1, which will act as our exit point from this while loop. Right, guys? Cool. So now we just need to print our path for which we can traverse the path in reverse order. Uh, Manual printing, guys, nothing new. So we have printed our path. Now we need to write a BFS function, guys. Basic BFS void. So instead of src is equal to 1, we need to initialize our visited array with 0 and distance array with minus 1, guys. I hope you are understanding. And distance of src is of course 0, guys. And let's take a queue, general BFS, and queue dot push src. We need to push source in our queue now. General BFS while loop. I think you guys, you have studied all this in the earlier part of this course on graph in the graph section. Now, guys, we need to take the front node of the queue and then pop the queue. So third of node if not listed of child. Right, guys, so listed of child equal to 1. So guys, distance of child is equal to distance of node plus 1. Parent of child is equal to node. Right, guys, so we have written our BFS. Now I think we can run this code. So I think there is some error. Right, guys. So let me so we have in the BFS function we have instead of source is 1. distance of source and parent. Okay, guys, parent of source we forgot to initialize as -1, guys. Cool. So let me check this, guys. So we forgot to push the child in mode, guys. Basic thing, guys. Now let's run this code. And we have our answer. The distance is 3. So a number of minimum computers node is 3 and path is 145, which matches with the sample output given here. So I think we can submit this code, guys, right? So let me use the file. 5 equals the 17. Cool. And submit it. So guys, the solution is accepted. Cool. So this was the code. I hope you understood the problem and you will be able to take away good ideas from this problem. Right, guys? That is all from my side.